but yeah, like this polygon right here has 4 faces. This is a quadrilateral, and not 4 faces, 4 sides rather. So this thing right in here, this polygon, we are calling this a face. Okay. Face is just another term that we use to mean polygon. Okay. Now over here we have a lot of points. Well, not really a lot. We have 4 points. You see, there's this P1, P2, P3, and P4. Okay, so we got 4 points right in here. And these things, these points, we are going to call them vertices. So this is one vertex. This P1 is one vertex. P2 is another vertex. P3 is another vertex. And so is P4. Now all these vertices, or all these points, they are all points in 3 dimensions, right? It's a 3D world, so points are in 3 dimensions. So each of them will have 3 coordinates: x coordinate, y coordinate, and z coordinate. Is this thing clear? So this simple cube, the one that we have right in here, this one has how many vertices? 3. How many vertices does a cube have? Well, we have 4 on this side already. 1, 2, 3, 4, and there is another back face, so you need 4 more. So in a cube we have 8 vertices, and I'll show you those vertices in a bit. Let me delete this for now. So what I'm saying, let me go into the wireframe view. Can you guys see this thing? In Blender, if you press Z, you can go into wireframe view. This is the solid view, and if you press Z, you go into wireframe view. If you want to come back to solid view, you press Z again. So just Z for going into wireframe view, and in the wireframe view, we can actually see through the whole thing. So when you do that, you can actually see that the vertices are over here. Let me number them. Let's say this is vertex number 1, this is vertex number 2, 3 over here, and 4 over here. So here again on the back side we have 5, 6, 7, and 8. Is this thing clear? So in a cube we have 8 vertices. Now if I give you all these 8 vertices, will you be able to construct this cube? Yes, you can. You just need to join up the faces. However, this construction is not unique, and you can make different sort of faces and shapes with these 8 vertices. See, we are joining 1, 2, 3, and 4 to make up a face. Now, instead of doing that, if you're only given the vertices, what you could do is you could also come up with faces like this one. Well, you get the idea. So 4, 5, 6, and 3, if you join them, you get a slanted face just like that, which wasn't present before. So what I really want to mean is that if you're only given the vertices, you can't really uniquely construct an object. There can be many different ways of constructing that some people may join 1, 2, 3, and 4 to construct a face, and someone else can join 5, 6, 3, and 4, which is not a face in our solid. Do we have a space in there in a slanted way? Like if you look at this object, it's not a good representation, but let me show this, that we have a face over here, we have another face over here, another face over here. There is no face that goes right through, right? There is no face like this. However, if you're given all these vertices, we can join them randomly as we like to make a face. What is the minimum number of vertices you need to make a face? 3. With 3 vertices, you can make a triangle, and a triangle can work as a face. If you have 2 vertices, you can only make a line. It's not going to enclose any area. So it's not going to be a polygon. 2 points can't make a polygon, but 3 points can. 4 points definitely can. 5 points also that's possible. You can make a pentagon out of it. That's also a polygon. So at least you need 3 points to make a face. And if you're given 8 points, you can pick any 3 points from there to make a face. So there is a problem that if you're given only the vertices, that's not enough to construct the object itself. It's not enough to say exactly how the object is going to look like. Is this idea clear? If I just give you the points, only the points, you can't really construct this thing. And let me give you another idea. We know about Orion, right? The stars that look like someone shooting arrows. Okay, so we have this Orion, and you have to sort of imagine that, well, this guy is shooting an arrow over here. Now, if I just give you these stars, is it the only shape that you can imagine from here? What if I want to join them in a different way? I can make different objects just from those stars. I can imagine different things, right? If you look at clouds in the sky, do we all see the clouds in the same way? Do we all imagine the same thing? No. And it comes down to the same concept that, well, if you're just given the points or the vertices, you can't really construct the object from there because there can be many different things. So we need to tell exactly which vertices should make up a face, not just the vertices. We also need to define the faces themselves. Okay. So here we have this cube. We can say that there are 8 vertices. And how many faces do we have on a cube? 6 faces. 8 vertices, 6 faces for a cube. So we need to tell for each of those 6 faces exactly which vertices we took to make up those faces. Okay, so if you numbered them, you have to tell that 1, 2, 3, and 4 they'll make up a face, and 5, 6, 7, 8 they'll make up another face, and there would be, well, 4 more lines talking about 4 more faces, because altogether those 6 faces will actually enclose the whole thing which this box represents. Okay. So today what we are going to do is we are going to see how these things can be written out to a file, and those files, they can be loaded back into Blender or really many other tools. So the basic idea is to represent these objects as polygons so that we can have an interchangeable format that can be used for many different graphic applications. It can be some computer programs, it can be 3D Studio Max, it can be Blender. All major computer graphics modeling tools, they understand this particular format, and I'm going to introduce to you right now. So we don't really know much about Blender yet, I mean, unless you have tried for yourself already. What we have here is this viewport, and inside that we have this object. And if you want to save what you're doing in Blender, you can just hit Ctrl S. That's super easy. It's just the same as saving your Excel file or Word file. We follow the same process, right? Ctrl S, you save a file, and based on the application, you have different file formats. So if it's a document, you save it with a .doc format. If it's an Excel file, you save it as .xls. If it's a web page, you save it as HTML, right? So Blender has its own format, and it's called .blend, B-L-E-N-D. Okay. So when you're saving something, and it's always a good practice, because everything that we are going to model is going to take a lot of time, and you don't want to lose what you have spent so many hours doing. So this assignment that you're given, that you have to model a L-shaped desk, is going to take a lot of hours. So what I would recommend is that you keep saving your work, and you keep multiple versions of your work as you go along, so that you can go back to something if something doesn't work out. So let's say this cube thing that we are working on, we are saving this as a blend file. Okay. Now I can close this document, this blend document, and I have cube.blend on my desktop. If I open this up again, I get the same thing, right? So that's how we save and reopen a file as we need. However, this cube.blend file is not really something that other programs would understand. Like 3D Studio Max may not understand what a blend file is. It's a different application, and this is a different application. This Blender is a different tool. So we need to have something common that all these applications can understand. And also for me to communicate this idea, I mean, this is going to be easy for me to show because, well, it's a text format. What you can do is, when you work with this cube, you can export it as a wavefront OBJ. And let me do it right on the desktop. I'm saving this as cube.obj. Okay. So I am going to write it down as I did for the other section. The step was File, Export, Wavefront, OBJ. So the file format is .obj. These are the object files. Okay. Now we have this cube.obj file over here. We can open it up, and as you'd see, it's a plain text file that we can read and understand. It's not really that difficult to realize what's in there. These lines, these are for comments. Okay, and this one we're not going to really go into this right now. This is about material. All these faces, you can say what color they're going to be, how much light they're going to reflect, all those things. Okay, we can define the material type in another file called .mtl file. But the rest of these things we will go through. Some of those we will skip again. Now what the first line says over here, it says O and then cube. It means we are defining an object called cube. This O stands for object and cube is the name. Any idea about these V lines?
Vertices.
Yeah, these are all vertices. Okay. How many lines do we have? 1, 2, 3, 4, 5, 6, 7, and 8. So we got 8 vertices right in here. Okay. Why do we have 3 numbers for each vertex?
X, Y, Z.
X, Y, Z, right? So that also makes sense. Now these 2 lines use material. It's about using the proper material that you define in the other file, and I'm not going to talk about it right now. Let's skip that. This is off means smooth shading is turned off. We will look into smooth shading in a bit, and also we'll talk about the mathematical foundation behind it, but not in today's class. But if you look at the next 6 lines, they talk about the faces, right? A cube has 6 faces, so we have 6 lines. Now, what could F1, 2, 3, 4 mean? Exactly. Which vertices make up that particular face? So, these B lines, each of them, they are numbered, although we don't see the number right away. Okay. So let me edit this just to show you what this really is. This is vertex 1, this is vertex 2, vertex 3 and 4, 5, 6, 7, and 8. So this face line 1562 really means that you take vertex 1 from here, and then vertex 5 from here, vertex 6, and also vertex 2. 1562. We know the vertices because all these data are here. Okay. We can pinpoint their coordinates. We know the x, y, and z coordinate for this vertex, for all these 4 vertices, and we can draw a face with that. And for that matter, we can do the same thing for each and every one of those things. Okay, so let me show you how this thing really works. Let me edit this thing back. Okay, so this is how it was, right? And this is our original cube. Okay, let me try something different. Let's open up a new window, and over here I have deleted the default cube. We don't have anything. Okay, as we can export something into a text file, we can also load it back into Blender. Okay, see what we did there is that we went to File, Export, and then exported as an OBJ. So there's another function that goes the other way, File Import, that we can import from a text file. This operation is exporting the 3D model into a text file. We can take a text file now and bring it back to Blender. So let's try that out. File, Import, the same thing, waveform OBJ, and let's go to desktop and find our cube object. See, the cube is there. That's exactly the same object that we have exported, and we can bring this back now. Is this clear? So let's try to do something fun over here. I'm deleting that. We have this cube file. This is a text file. I want to edit this text file and reload that back into Blender. As we have said that we have 8 vertices over here, and there are 6 faces. Okay. If we delete some of the faces, can we have a different representation there? Let's say I'm deleting all these faces. Okay. Let me save this file now. If I go back into Blender and go into File, Import, Wavefront OBJ, and pick this cube object again, see? I just have one face. And that's exactly what we have. We have 8 vertices, but they don't really matter because I have only defined a single face over here. If I have other faces, let me come up with a random face. I don't really know if this is going to work, but let me just do this. 5, 2, 6, and 7. Okay, I'm saving this file. We are going to import this again, import wavefront OBJ. So let's get that cube object again. So we have this face over here. The bottom face was there for 1, 2, 3, and 4. And since I said 5, 2, 6, and 7, this is definitely 2. 5, 6, 2, and 7. It's actually a quadrilateral, but it looks like 2 different faces. Is it possible to make a quadrilateral look like this? Yeah, it's going to be a problem. I'm not saying that this is going to be the ideal scenario, this is how you're going to work, but I'm just trying to establish that there is a relation between the blend file, the 3D object, and the text file. Is that thing clear? And if you're wondering if the face right here, if it's a polygon or not, just look at this page over here. This is a blank page, right? This is a quadrilateral. It has 4 vertices over here, and these 4 vertices, they make up a face, right? If I If I fold this paper and bring up a crease, just like this, how many vertices do I have? Still 4 vertices. Does it still look like a single face? No, we have 2 different parts. Okay? So that's exactly what has happened. Based on my choice of 4 vertices, we ended up with this. Okay? And it wasn't really necessary to pick 4 vertices every time. We can also come up with 3 vertices, because as you guys have said, that you need at least 3 vertices to make a face. If we do that, let us import it one more time. See, we have a quadrilateral and we have a triangle. Okay. So we can now say that we can type this OBJ file by ourselves to make a 3D model and load it up in Blender. Right? Because I'm able to edit this, so I can create this file from the scratch and write out all my vertices, all the faces, then I can load it back in Blender. And it's not only Blender, we can use this in many other 3D applications like 3D Studio Max, Autodesk Maya, and also there are many websites where we can showcase our models, we can export, or we can upload the OBJ files over there, and they will show our model in a 3D viewport. So the viewers, when they go to that site, they're able to look at our models from different angles. So I'll show that to you in the next class or the one after, where you can submit those things. It's actually a way to promote your work. You can build up your portfolio. If you're looking for jobs related to this field, you have to show people that you can build these things. So that's like a portfolio, and every artist should have that. But I have done these things, I have built these models, and I can do some work. Even if you're working on a project, most CVs that you see these days, they will post a link to their GitHub repository that these are the projects that they have worked on, so that whoever is hiring them, they have a clear idea of quality of the work or what they know already. But that's really going into another topic. Let's get back to what we had here. Is that we can write our faces and we can write our vertices to come up with any shape that we like. So that's what I meant by talking about OBJ files. That we can create our models, we can save them in blend file, but really though, when we try to export it for any other application, we have to speak a common language, and Blend is not a common language. This OBJ file is something every other software would understand. And this idea is not really uncommon to you if you're into playing computer games. Most times, most of the computer games, or even on mobile, if you have a large game that takes time to load, you'll see that it has some status messages coming up. Like they'll say loading maps, loading objects, loading textures, those sort of things. So what they are really doing in the background is that they are loading up these files. So every character, human-like character, or every building, every floor, or every hill that you see in computer games, they're all polygons. There are thousands of polygons. They have their data written out in some text file. I'm not going to say that they're all .obj files. Some games may use .obj files, but there are other more popular formats for them. Some of them are .mdk. There's also Collada's DAE files, and you can also export from your Blender application. You can export into those formats as well. It's just that those formats are a little bit more complicated than this OBJ file, and it's not really suitable for me to show in the class. But this is really easy to understand because it's very simple. You had some V lines and you had some F lines. V for vertices and F for faces, right? So this is simple enough. So that's the relationship between the objects, the 3D objects and the polygons that these objects are made up of. Now in today's class we are going to go into a bit more about building some 3D shapes like a chair, like a desk. Your assignment is about building this L-shaped desk and all these objects that are on it. And based on what we are going to see today, you should be able to get started at least. Okay. So what I did in the other class is that in the first class we built a chair out of some cubes. So I'm going to go a little bit differently over here. I'm going to make a desk. Here. So let me load up a Blender. Let's go with a fresh thing. So this is the default view, right? We got a cube by default, and we can turn this cube into different sort of objects. Okay. So if you're looking at a desk, I mean, this is a little bit. Well, we can also try this one. So let's say we want to make a part of this desk, not the whole thing. Let's just go with this part, the ones that you have over there. Okay. If you try to make this desk, first thing you'd notice is that it's not a whole box. There are hollow parts. We have a tabletop right in here, which is pretty thin, right? This cube itself is like a box. So we need to squish it down to make it flat. Now Blender has all those features, and to understand that, you have to understand that there are at least 3 basic affine transformations that you learned in coordinate geometry. We learned how to translate points from one location to another. We learned how to rotate points. We also learned how to scale points. You guys remember those things? I'm not asking about the math, but it is the concept of those things. We had translate, rotate, and scale. Okay, we are going to use some of those things over here in Blender. So first things first, let's go for translation. Let's say we are given a cube over here and we want to move it around. In Blender, it's easy to move things around if you just use the arrow keys, just like this. Drag along with the arrow keys. You can move this object with that handle. So if you want to move it up, you go up in the Z-axis. If you want to move it inside, move along the Y-axis. Is this thing clear? That hold down the arrow that represents that particular axis, and you can translate. You can translate around along the X-axis or the Z-axis or the Y-axis. So translation can work. I'm going to undo what I have done, and to undo, just like any other application, you do Control Z. Okay, so I'm undoing this. So this was translation, right? So if I want to translate along the X-axis, say this is over here, and I want to translate 2 units. I want to translate here, and then I want to translate there. So that's translating 2 units, but I'm doing just by looking at it, right? Sometimes you wouldn't want to do that. Sometimes you want to have a freedom to take this object, move your mouse, and put it somewhere else. I mean, this is a bit constraining you, like I have to move along a particular axis, and I don't want to do that all the time. So what I want to do is I want to grab this object and move it to some other place with full freedom. Okay? The way we do that is by pressing G. So let me write it out. We're talking about something called affine transformation. I'll tell you exactly what this means. We'll look into the math aspect, but that's not for today. One of the things that we learned in affine transformation in coordinate geometry was called translation. Okay, and here in Blender, we are going to call that same thing with a different name. We are going to call it grab. Okay, and the shortcut for grab is G. Translation is the same as grab. So when you go here, you select an object. In Blender, you select something with just by clicking the right mouse button. So if you want to select this, you right click on it. If you want to select this, right click on it. So let's say I want to translate this lamp now. I press G and bring it to some place over here, and then we can render this, right? Or we can grab this and move it over here, then this side will get some light. See? Now that's better. So G is for grab, and you can pretty much select anything and then grab and move it somewhere else. Is this clear? And this goes along with the translation that we learned in coordinate geometry. However, in coordinate geometry we learned only how to translate a single point, but here we are moving a whole box. How is that idea related to this? Let me remind you what we did there. So let me quickly draw this Greek paper, or some part of it. Let's say this is our grid, and we have a 2D coordinate system. And let us imagine that this is our origin, this being the x-axis, and this one's the y-axis. All right. So let's say we have a point P over here, and I want to translate this. What's the coordinate of P right now? This is 2, 1. So 2 units to the x, 1 and 2, 2 units to the x, and 1 unit to the y. Right? So 2, 1 is the current coordinate of P. And if I want to translate this by h equal to 1 and k equal to -1, can we do this translation? We can translate a point by hk unit. H is in the x-axis, y and k is in the y-axis. So what's going to be the new location of P? Three zero. P right now is over here. If I move it 1 unit to the right, it goes over here at 3, 1. But I'm also going -1 unit, so it goes down. So it comes down over here, so you'll have P prime over here. So this is like a translation. P goes from one point to another. So this is what we learned in coordinate geometry. Now I'm asking, when I do this thing, when I take this cube and I grab and put it somewhere else, how are we calling the same thing, translation? How is this translation again? Because in coordinate geometry math course, we learned how to translate a single point. That point was P, right? We can translate one point from one point to another in 2D, and we can also apply that in 3D. 3D is not a big deal. But over here we have this cube, and we are also translating this. This is exactly the same thing, because this cube is actually made of a lot of polygons. 6 polygons to be exact, right? We got 6 polygons that we are translating. Now these polygons in turn, what do they have? They have vertices or points. So once done, we need to translate each and every point that you have for this object, move them to another place, and you still have the same object. It's just that the location has changed. Okay, so this is a translate operation. So we're going to do that from time to time. We have translate. We also have rotate. We also have scale. Now, just to remind you, what was the shortcut to translate something?
G.
G for grab, and that's what we call translate. You can also translate in a particular axis. You can press G followed by X, and then if you move around, you're only going to move along the X-axis. So that's the shortcut. GX is for moving along X-axis. GZ is for moving along the Y-axis, and obviously GY to move along the Y-axis. Okay? So that's grab or translate. We can also rotate with R for rotate. You can fix a particular axis, so if you say RZ, then that Z axis will be fixed and you're only going to be able to rotate it like that. Is this clear? Let me take this water bottle right here. Let's say we have an imaginary Z axis that goes right through in the middle. If we rotate it, it's going to rotate like this along the Z axis. Let's say the X axis is right here, and if you rotate along the X axis, it's going to rotate like this. Okay? And if you have a Y axis that goes right through from this point to this point, then when you rotate this, it's going to look like this. So 3 different rotation around 3 different axes. We can control them by locking the axis. So Rx locks the X-axis, Rz locks the Z-axis, and so forth. So we look into the rotation. We can also relate that to what we learned in coordinate geometry, and I'm going to go into that in the math part when we get there. But we also have something called scaling, and the first letter for scaling is S. So Blender has that as a shortcut. You can press S to scale an object, and if you bring your mouse out, it's going to get bigger. If you move your mouse inside, it's going to get smaller, and that's what scaling really does. It makes us an object big, or it makes something small, right? Okay, so again, similarly, you can do SX, and it's only going to scale along the X-axis. If you press SZ, it's only going to scale it's only going to scale along the Z-axis. And this is a good opportunity for us to make this tabletop with this scale operation. How? Well, if you do SZ and go inside, see, that's a flat tabletop right there. Is this thing clear? And if you want to make it wider, or longer rather, you want to scale along the X-axis. So you say SX, and then you can make it bigger, just like that. It's easy, right? So for this to be a table, we need 2 sides. Well, these side panes, we either need the legs, or we need like pins like this that stand vertically. How we can get those? Well, we need new cubes and make them really thin and put them on the side. So you go into the tool shelf and bring a new cube. This is the cube, and let us squeeze it down on the X-axis. So scale X. Okay, let's make it a little bit smaller on the Y-axis. So SY. Okay, that should do. And I want to use this thing on the side, right? So this is the time I need to move it along in the X-axis. So I can use this or GX to move it there. Or now let me show you the other way around, GZ, and I can bring it down. It's taking a shape of a desk, right? We have at least one side ready. Now we need the other part. So it's going to be the same process that you go and bring a cube, squeeze it on the x-axis, and place it in the appropriate place. We can do that. However, there is an easier way to do this. You can make a duplicate of any shape that you create. So Control D, let me select this. Control D, oh no, Shift D is actually for duplicate. Sorry, I messed it up. Shift D is for duplicate, and then it allows you the freedom to move it to whatever place. Okay, but if you press Escape, then it goes back to that place. Okay, why I pressed Escape? Because I want to move it along the x-axis only. I don't want to mess up with the other ones. See, that's my disk already. Is this clear? So if you now need to close this down, we can again do that with a cube. Right? How so? Well, there are many ways to do that, but let me use one of these things. Let me duplicate this thing. How do we duplicate? Shift D. So we got a duplicate, but we need it to be flipped around. So you can rotate around the z-axis. See, this is turning. You can turn this so that it becomes 90 degrees like that. Okay, you can use your eyes and your calculation to do this. However, it's easy to do RZ90. You just type it in, RZ90, that's exactly 90 degrees rotation, and we sort of have this thing in place. We need to bring it out though, over here. We also need to move it somewhere in the middle. Then we need to scale it on the x-axis, make it bigger, so that it covers the whole thing. So we have this huge thing that goes along like that, and that can be one of our desks. Like, I mean, this is not a bad thing. Some of our desks do look like this, that we have only one side open so that we have some leg space, but all three sides are closed, just like this. And if you want to make this shorter, well, that's easy too. Scale along the z-axis and then move it up just like that. And now it sort of looks like one of these discs. Okay. So is this idea clear? That we can get multiple objects. We can create a new object with composing by using a lot of objects. Like we have 1, 2, 3, and 4 cubes to make up the structure of this disk the way it is. Okay? And you can save this file. You can also export it. Let me save this as it is. And we can also export this thing as an OBJ file. And just for completeness, where's our disk? I haven't exported this, I guess. File, export wavefront OBJ. Okay, I already have it. Let me see this. So I have this disk.obj. I can open it up over here. See? It has cube 003. It has cube 001. So these are the objects that we have. And we can have all these vertices like this, all the faces like this. Now this looks a little bit different with VN and some new entries with the faces. But let me make this simple. file, export, away from OBJ, I'm going to uncheck two options. One is write normals, the other one is include UVs. Let me zoom this up so that you guys can see. So right at the bottom part on the left side, there are a lot of options, and one of those is write normals and include UVs. Those are checked by default in my system, so I uncheck those. I unchecked those and I exported this thing again. So what I get now is only the V lines and the F lines, like what we were discussing before. Okay. So this whole object is made out of 4 cubes right here. They don't really look like cube anymore. We have transformed that into something else. And I'm not going to go any further today, but in our next class we'll see different approaches to do the same thing. We will take an object, we will cut it up, introduce new vertices, and make a whole object out of that, one single thing. Here we are piecing together multiple parts to build one object. But then in the other approach that we'll see, we'll have a single object, we will cut it up and make multiple parts going different directions from right there. But that's for another class, not for today. So what I would suggest that you watch the first 10 videos of the tutorial that I asked you guys to follow, Born CG's Blender tutorial. If you follow at least the first 10 videos, you should be ready to work on assignment number 1. Okay. I'm not saying that you have to learn them through a tutorial. I'm going to cover all those things in class, but that's going to take time. And this Ramadan is not really helping. My class hour got reduced, so that's another thing. If you want to work ahead on the assignment itself, please watch those videos so that you have those concepts already. But we will get there within the first, within next week. So we'll have most of those concepts ready that you need to submit this assignment. But get started working on it. It's going to take quite a few hours to do this very simple thing. Okay? And the one thing I would suggest is that if you're working from home, take your camera or your phone, take a lot of pictures of these workstations so that you have a visual cue when you work. How these desks look, what are the things that are on it. Okay? Take some pictures of these tables so that you can work from home. Any questions? It doesn't have to be round shape like that. The cables, they will be problematic too. Okay, there are ways to do these things, but well, if you can't, then that's understandable. I mean, those are fairly advanced. The way you're going to make the cables, those are more difficult. The mouse is not so difficult. You can sort of approximate that with cubes. I'll show you how you can edit the cube to make something curved. Okay, it's possible to do. Mouse is not really difficult. It's more difficult than the disk itself, obviously, because this is a very flat shape, but we can also make round shaped stuff as well. Alright, so that's gonna be it.